Alright, in problem number 2 we have a square that's inscribed in a semicircle. And we're told that the area of the square is 40. Okay, I guess we don't know the units of that, and we're asked to find what's the area of the semicircle. Well, I guess, what do I need to know to figure out the area of the semicircle? So first, the area of a circle is just pi r squared, right? So a semicircle would just be half of that. Alright, so if I knew r, if I knew the radius of the circle, I'd be in good shape, right? But I don't know r. All I'm given is this square. Now I'm told that it is a square, right? So I know that, you know, these are all 90-degree angles and that the side lengths are all the same. The sides are parallel, the opposite sides are parallel to each other. I know that. So let's see what we can do with that. Alright? So first of all, if I'm given the area of 40, then what does that mean for a side length? So the side length is just the square root of 40, right? The square root of 40 is equal to the square root of 4 times 10, which is 2 times the square root of 10. Okay? So I know that the side length of this square is 2 times the square root of 10. Okay? And I know that's the same for all of these sides. And I also know, because of the symmetry of a square and the symmetry of the semicircle, that I ought to be able to, you know, that this if I were to draw a line down the middle here, this would be a line of symmetry for both the square and the rectangle. Or sorry, the square and the semicircle. Okay? And I also know that, okay, if that's the line of symmetry, then this has to be the center of the circle. Or what would be the circle? The center of this semicircle. Okay, and then I can draw a radius. And I can draw a radius anywhere to the edge of the circle from the center. Okay, but I want to draw it, you know, to an advantageous spot. And so I would like to draw it to a point where the square is touching the circle. Okay, that's kind of an advantageous spot, because then I have, you know, I kind of make this triangle here. Okay, and let's see, we know this is 90 degrees, right? We know that's a 90-degree angle. We know that this is a line of symmetry, so if the side length is 2 times the square root of 10, then this is the square root of 10 here, this from the center to the corner here of the square. That's the square root of 10. This is 2 times the square root of 10. We're given a right angle, so I can use the Pythagorean theorem to find the hypotenuse, and the hypotenuse is the radius of the circle. So let's do that. So the hypotenuse is equal to, well, actually the hypotenuse squared, let's just, it's what c squared is equal to a squared plus b squared. Now when I put c squared, I don't mean this c. I just wrote that as the center, so maybe I'll get rid of that, just so I don't confuse you. But you know, a and b are the two legs of the right triangle, and c is the hypotenuse. So square root of 10 squared is equal to 10. 2 times the square root of 10 squared is actually, you know, square of the square root of 40. I probably could have just left it like that. And so that's 40, so we get 50. So c squared is equal to 50, and that means that c has to be the square root of 50, and, ooh, what's going on? This is square root of 50, and so I know that 50 is 25 times 2. 25 is a perfect square, so I'll write that as 5 times the square root of 2. Alright, so I know that this side, the hypotenuse of this triangle, is 5 times the square root of 2. And I also know that that is a radius of the semicircle. And that's what I want to know, right? Because once I know the radius, I can plug it into this formula and get the area of the semicircle. Alright, so let's do that. So we get that the area, let's see, I'll just write it over here. The area is equal to pi times 5 times the square root of 2. I guess we had the square root of 50, so let's just make it 50. Okay, so it's 5 times 50. I guess I didn't need to take the square root of this because I already had c squared. And then I divide it by 2 because I'm only dealing with half of a circle instead of a full circle. So that gives us 25 pi for the area of the semicircle. Alright, so there you go, there's the answer.